All right, this is where we left off last week. Um, this week's main focus is going to be aligning the workpiece to the machine system. Now, this is a little different than running, let's say, a vertical milling machine, where in the mill you have to bring the workpiece to the alignment on the machine. So you got to indicate the vice joint, you got to indicate the part in, things like that. The CMM is a little different, where you bring the software or the program to the part, and the machine will move based on that alignment. So you don't need to have real solid setups here as far as indicating the part in and whatnot. The machine will do that. Okay, now you don't want to be off by 1/8 of an inch, but if this part is kicked, like let's say if we go, let's just go to the top view here from Z Plus. If you're kicked, let's say like that a little bit, and you're out at a clocking this way, the machine will square it up in the program and align itself. Okay, as long as you're not way out, the software goes to the part. The part does not necessarily go to the software, if that makes sense. So we'll go back here and let's go isometric. So what we're going to do is what's called an alignment. Okay, we'll get into characteristics and features in a minute. Let me delete that. You'll be blank like this. Now, features are basically what we're checking. Characteristics are the measurements of those features. All right, so again, features are actual geometry. Characteristics are the measurement of those features or relationships between them. Now in the measurement tab, all right, we are going to go to base start alignment and click that, and then we're going to create a new, it's going to be create a new base alignment right here. Standard method is fine, so hit OK. And what we'll do now, okay, is we are going to take care of these boxes. All right, spatial rotation takes care of all of this movement. So anything that would make this plane right here not perpendicular to the z-axis of the machine. So you can think of this as sort of squaring the head to the Bridgeport of the Bridgeport. It makes sure the spindle is perpendicular. Okay, planar rotation is like indicating the solid jaw on a milling machine, where this controls, like if I go to top view, okay, this if I rotate it this way, and again I could spin about an axis, but whatever for now. If this thing moves this way, okay, planar rotation clocks the workpiece. XYZ origin is just like setting a work offset on the CNC. It's a hard stop. Okay, so this constrains all 6 degrees of freedom, just like the datum alignment concept in geometric tolerancing. So let's start here and take care of our spatial rotation. Okay, right down here to the left, okay, click in here, and you're going to select define select geometry. It does not default to that, so make sure you click it. So click that. Once you do that, just select the top plane, and you'll see plane 1 is takes care of the z positive axis for spatial rotation. Okay, and that is also z origin. All right. Our next step is going to be creating a not only XY origin, but taking care of clocking the workpiece. So to do that, this could be a plane, but generally long, thin planes like this should be, you should do them as a 2D line. You're just not going to get enough data from it. It becomes unstable. So you go back into this box down here and go to define line on a plane. Click and hold right here, and then draw the line over, clicking and holding the left mouse. Then let go. And you'll see a 2D line. The direction of that line is critical. That takes care of the X positive. All right, this is the direction of the line. Okay, so now the X direction, X positive right here, matches this line, matches the new or the preview of the work coordinate system that we're seeing right here. It also took care of the Y origin. Now what we can do is go to line again, define line on a plane, and I'm going to click and hold, and there's that one. So now you'll see that we have spatial rotation, planar rotation, and all of the origins set. All right, that is a basic alignment. Now when we hit OK, you will see that our gnomon or work coordinate system or our 0, 0 is aligned properly to the lower left corner of this workpiece. All right. So I'm going to pause there and allow you to catch up, and we'll continue. Alright, so now that we have the features assigned for our alignment and we have a green box here, the alignment is done. But we're missing some information. One thing in Calypso, you'll see these green, reds, and yellows. Red is bad, green is good, yellow is kind of in limbo. Alright, so just something to think about. There's also, when you get into characteristics and features, there's like a magenta. Be aware that that is sort of like not enough data. Alright. What we have to do now is actually tell the machine how to contact the features we called out. On the ones at school, there are defaults set, and sometimes I delete those. But right now, I have everybody starting from scratch. So first thing we need to do is set clearance planes, and this is where the probe will go as it moves around the workpiece, all right, in order to not hit anything. So we're not taking into account any clamps or anything for this. I'm not worried about it. I'll show you fixturing later on. The fixturing is very light on this setup. I'll take pictures and show you on the machine. I'll show you this program run on the actual CMM. But for clearance planes, just click it, and then I'm going to do clearance plane from CAD model right up on top. The it's almost 400,000. That's fine. Hit OK, and just hit OK. And update clearance plane settings for defined features. No. All right. So make sure you hit no there. Otherwise, things can get kind of weird with what it's calling out. And I'll show you that in a minute. So clearance planes are good. Base alignment is good. Now we have no characteristics because there's no measurements yet. But what we need to do now is look at our features. So I want you to double click on the plane, and you'll see this is the basic information on the plane. You can put comments in on the plane in the program. You could rename it. You could tolerance it. There's a clearance plane group. Again, that can get screwed up if you hit yes on the previous screen, so be careful of that. Different options for feature recall. Nothing to worry about there for us. It should default to pretty nominal numbers. You're not going to see weird numbers on programming offline, which means programming with a model. You will if you're programming with the part, because the part is not perfect. Okay. So what we need to do is go to strategy. And in strategy, you'll see there's nothing in this window down here. So we're not going to do any scanning yet. What we're going to do is we're just going to take 4 hits. Okay. And you'll see the hits appear here. If we use the left mouse button and click on the model. Okay. You can just delete those screens, and you'll see, all right, we're in pretty good shape except for these 2 points here. These 2 are good. Those 2 interpreted down here. So what I'm going to do, and that's fine, is I'm going to find those 2. They actually, they're yellow if they're not being selected, but if they're selected, they turn like a pink or magenta. Just delete them. Okay, and then we can add a couple more points. And how you select becomes critical. Now, if that screen keeps popping up, usually I just minimize it. But we'll select here and just minimize, and it won't pop up as much. Make sure the little dots where you see the points are actually on this plane and not through the workpiece. That is very helpful. Now, that's where the machine's going to contact to reference this plane. All right, so this is what you're looking for, 4 points. There's different options here. You can automatically create grids and things and make polylines or paths from it. We'll do that in the future. Right now, let's just do some points. Okay? So we'll hit OK, and then we'll hit OK again. Notice it turns green, so we're good there. Just do the same thing for the first 2D line. Now this probably defaulted to a line autopath. That's going to automatically scan. We'll live with that. That's fine. If you double click on this line autopath, same thing with the points in the plane, but there's no need to edit it. You can change the step width. You can change how many points it takes. You can extend the line. Different scanning options, different evaluation ranges. There's a whole lot of different things you do as far as how this machine interprets the data. But for right now, we'll leave it as default. Line autopath is fine. And we will also leave line 2 as default. Okay? So that should be all set. And pretty much what we need to do now is we need to actually just run this. Okay? So in order to run a program, okay, since this is the controller, if you hit run, you're going to have problems because it doesn't know it's in simulation, really. To tell it it's in simulation, you need to go to the planner and go to measurement plan simulation, and this will come up and you'll see the stylus appear. Okay? Now what you need to do is then select run. This becomes critical in here. You want to select clear existing results and go to example part 2 for your alignment. Ignore my other ones down here. That weird yellow is usually a bad sign. So for right now, just go to example part 2. We'll cover current alignment, manual alignment later on. We'll do more advanced alignments probably in the future. So let's just hit start. And you will see this go through and actually contact the workpiece. Scan this line, or take points. Okay. Again, these machines are full scanning capability, but we'll just take points for these. I thought that, off the top of my head, I thought it defaulted, but I did erase all of my default parameters. So, because typically we don't, there's nothing there. Don't worry about that. There's no features for, there's no printout. We just need alignment. Basically, we do usually default to scanning. So we would actually scan this, and scan this. But for the sake of showing you the basics and using the same version and the same, starting from scratch that you guys are, I ended up having to go back and deleting some of my parameters. Apparently I missed that one, which is fine because that's exactly what you're going to see. So that worked out. Again, this is still on. Okay, if you hit run again, you can watch it again. And you can slow it down here. Okay. You can watch it run. And that's what it's all about. Now, you can import fixturing. There's things you can do with that, but for right now, this is all we're looking for, is to actually create our alignment, create clearance planes, take a look at some of the strategies for the individual features, and then just run it using simulation. And if we can get that through that is excellent. And then next week, we will continue with actually getting some data and getting a program ready to run. So if you have any questions, email me. That's it for this one, and I'll see you next time.